All right. Yeah, it's awesome to be here again. And by the way, for those of you who are new to GraphQL and like have that was probably quite a daunting entry point to learn about GraphQL with all of the tooling and all of these advanced concepts. So for those of you who this is just like the first interaction with GraphQL, I can highly recommend getting started on howtographql.com. So this takes you like through really from zero to either a client-side GraphQL app or a server-side GraphQL app with any prior knowledge. So for the beginners here, I can really recommend that. So yeah, my name is Johannes. I'm based in Berlin and spend more and more time also in San Francisco, and I also work at Graphcool. You can find me with this handle on Twitter and at Schickling on GitHub. Today, I want to give you a quick overview over Prisma, what we launched last week. And a bit more practical, want to show you how you can build your own node-based GraphQL servers using Prisma with an actual live demo in the end. Yeah, so Prisma. Who of you has seen this last week on Twitter? Yes, great range. Awesome. So Prisma is very simple to explain. So you can kind of think about it as a GraphQL proxy layer for your database. So what you do is like you put Prisma in front of your database and you get a GraphQL API. And this is now really exciting because the GraphQL ecosystem has advanced quite a lot. So you have a whole different range of possibilities how you can use that. You can not just directly connect from the front end to this GraphQL API, but you can use it to build your own GraphQL server. And this is what I want to focus today on. So as said, Prisma is a proxy layer for your database. It generates a CRUD-style GraphQL API based on your data model if you're starting from scratch. And this GraphQL API can be used either from the front end or to build your own GraphQL server. And Prisma also provides some tooling around operating and migrating your database. So on a high level, how it works is that when you're starting out from scratch, is that you use GraphQL SDL to define your data model, and you get a fully functional GraphQL API generated out of the box. So again, GraphQL SDL, for those of you who are not familiar, it's a really simple notation to essentially define types that relate to each other. And this type definition is understood by a lot of tooling and is the foundation for the schema you're generating. So typically, you also have like another type that's called query. This type query has a special meaning since it's the entry point into your GraphQL API that you can query from. Here, for example, the type query, if there would be one, would have a field users where you then can traverse your GraphQL server. So as said, there are two ways to use Prisma. So either you connect directly from a front-end application. This is, for example, great if you're building out prototypes or if you're building internal tools where you're in a trusted context where you don't need sophisticated authentication authorization methods, or you can use that as a foundation to build your own GraphQL server. It's actually also really nice to do this in a incremental way. So that means you're starting out using Prisma directly from the front end for your first iteration of your first MVP, and then you put in your own GraphQL server and implement all of the business logic that you need. So then this is the second option, how you can use it. And what we've already seen in Jason's talk is that you can also use this for a gateway microservice pattern. So on a high-level architecture, it looks somewhat like this. You have a database. Currently, we're supporting MySQL. You put Prisma in front of it. Either you host it yourself using Docker. You can run it like this locally, or you can use it as a cloud offering. And you instrument all of that at development time throughout a CLI. So this not just works for a single database and a single server, but this actually allows for a multi-tenant system. So that means within a single instance, you can run a couple of different services. For example, like a staging environment or a testing environment or production environment, or if you set this up in your own infrastructure, that your entire company gets access to this and can spin up different apps. So let's take a quick look in the building blocks of how you would use Prisma. So the foundation for a so-called service, a service, it maps like a database to an actual GraphQL API, which has the foundation of the data model, and the entry point to all of that is your Prisma YAML file that contains a bunch of meta information, such as like what the service name is, which stage it is, on which cluster it is running. So a cluster, or a server, just where your database lives and where the Prisma server in front of it lives. And you can also set a secret to secure the authentication, and it points to your data model, which is the foundation for your resulting GraphQL schema. And the data model, as said, we looked at it earlier. This is where you just use plain GraphQL STL with a couple of directives which allow you to specify relations or certain constraints. And this is just a really intuitive way to define your data model. So whoever has spent a lot of time writing long SQL statements to sort of migrate your database and all of that, I think that's a really a lot more of an expressive way to define your data model that even front-end developers can understand and work with. I'm not kidding. So based on your data model, you get a generated GraphQL API. So if we look back at our data model here, we have a type user and a type post. So now you get an entry point to get all of your users. You can query the name. You can also traverse to the posts and traverse the entire relationship here. And this, you cannot just get all of the data, but you can also filter it. So whatever you could really express using a SQL where statement or aggregations, you can also now do this in this GraphQL API, with the advantage that it's just the tooling is a lot more advanced and it's a lot more intuitive, view on your data. And so it comes with all sorts of features out of the box, such as transactional mutations, aggregations, these relational filters, and even a real-time subscription API. So to interact with all of that, you basically use the Prisma CLI, where you can run Prisma init to set up a new Prisma service. You just deploy that. Basically, you select a cluster where you want to deploy to, and that migrates your service. And the way how you would then, or how you can interact with the generated API is using the playground, which CERN already presented earlier. But we see all of that in the live demo anyway. So, are you still with me? Do you have a rough understanding what Prisma is? Awesome. So then let's take a look at how you would build a GraphQL server using Prisma. Again, you could also use Prisma directly from your React application or your iOS application that connect directly. But today we want to see how you would build your own GraphQL server using Prisma. So this is probably what most of you who have built a GraphQL server are familiar with. So you define your type definitions, your schema, and then you start implementing the actual resolvers for your GraphQL server. Start that using Express or something like that. And then you have a operating GraphQL server. But let's take a look at a bit of a more complex example. So let's assume this is the GraphQL server. This is the GraphQL schema that we want to implement. So here we have a query called users with a type user that looks like this and a type post that looks like this. And this would be the GraphQL query that we want to issue. And imagine you're not using Prisma, but you would want to implement that yourself. And this is where you need to implement resolvers. And resolvers are really the hard part here. So who has tried to use GraphQL in combination with SQL, then this is probably looks quite familiar. And this is the simple case. This is like the case where you know, like, okay, this will probably be the case where the query that we're expecting. And if a certain other case hits, then you have like tons of nested if-else madness and so on. So that's quite complex. So mapping in general between a GraphQL API and a database is quite a difficult task. It can be that your data model maps quite nicely to your GraphQL API, and you use something like Mongo. But as soon as you want to really work with relational capabilities, you're back to having to do a lot of manual work. In the case of a SQL database, you have to think about which fields am I returning. So either you manually build a selection set and you say select name from and all of that, or you do select star, where you just return way more than you need to. And in general, whoever who has built a GraphQL server probably knows there are multiple ways to implement these resolvers. So either on a root level in the first resolver, you return just everything and kind of hope that at these deeper levels, it still maps to your GraphQL schema, or you implement your resolvers at every layer. But that's also a lot of work. So when we look back at this example here, what might already help and make that a bit look less scary is if we would be using an ORM. It comes with its own set of trade-offs and so on, and typically who's built a system with a bigger ORM probably hit always the same point in time where you just say, okay, either it gets to imperformant, or you hit this certain edge case that you really cannot express with this ORM, and you go back to writing your own SQL queries, and we're back here. But this is where GraphQL actually gives you a great new abstraction over your data. So what if there was like something like a GraphQL ORM, and this is how it would look like. So now let's think about implementing a resolver for the type user that returns your posts. And this is where it comes back to what Søren already talked about with GraphQL bindings. What you here really can do is if you have already a GraphQL API for your database that maps to the GraphQL schema of your server that you want to expose, what you can here actually do is you can just specify how you want to delegate your incoming query. So what you really here, you're delegating two things. So one, you're rewriting all of the sophisticated SQL, where, and so on. So all of the stuff that we have here, we basically pass in here as arguments in this nice typed manner. And what we've seen before, where you say, I'm interested in a name field and the ID and all of these relations, all of that we don't need to specify here because we're making use of schema stitching, which is done by this little info object here. So this info object, you don't need to know too much about it, but that's basically an implementation detail of how GraphQL JS works, and that contains things like the selection set. So this contains like the list of all fields that you're interested in. This contains stuff like if you're using variables in your GraphQL query, that contains the variables. This contains fragments and all of that. And what you really just need to do is you just need to pass on this info into this GraphQL ORM, and this figures it out. So using this sort of syntax, that would be really nice. That would be quite a big step forward from this. And this actually works. So this is based on GraphQL bindings. Since your GraphQL, the database that you're accessing, is just exposed as a GraphQL API. So we can just make use of all of the capabilities we have from GraphQL bindings, either dynamically or statically. Under the hood, it's using schema stitching that you don't have to write out all of the fields that you want. And yeah, essentially it just takes in a part of your query that's coming in and sends it off to your other GraphQL server. So the core problem, and when it comes to inefficiencies of an ORM, is really like not the case here, because an ORM is kind of like, you can think about it as a synchronous function. It gives you a nice API where you can construct whatever data requirements you want to express, and then you say execute. That typically does two things. One, it creates a crazy unoptimized SQL query, sends it to your database, gives you data back, and that takes forever. In this case, it just propagates the GraphQL query, which inherently is not slow or fast. This is handled by the layer below, which you can then really optimize. So benefits, I think we all can agree on that the API is a lot more intuitive to work with. We've also heard like from people that this like kind of makes a SQL database. It's not limited to SQL database, but makes the SQL database almost like as nice to work with as a Mongo API from the API perspective. Given that it's based on GraphQL bindings, it maps really directly to your programming language, which is especially nice if you're using typed languages where you can literally map all of the capabilities of your GraphQL API to your programming language. So for those of you who are new to GraphQL, GraphQL is basically a big type system, what we've seen before, and which comes with all of the benefits of a type system, catching errors if you have a typo somewhere at compile time, giving you nice auto-completion functionality. All of that, what your GraphQL API provides you to, you now have in your programming language, which is super exciting. And it's lightweight. Yes, we spoke about that. If you're using static bindings, you get nice IDE integrations, you get compile time, error detection, which reads as such a small thing, but that's actually a huge deal if you're building big GraphQL servers where you have a little typo somewhere which you've like written in the middle of the night, and then you get like nice red squiggly lines which tells you, hey, you're stupid. So this is how it looks like in action. So here we're just implementing a little example app, and you see all of the nice auto-completion here of all of your queries that your GraphQL API give you. So this is all just through GraphQL bindings here mapping to a Prisma API. All of what you see here is not limited to Prisma at all, that you can use that for any GraphQL API, for the GitHub GraphQL API, Shopify GraphQL API, for your own GraphQL microservices. This is really just an example here. So in terms of using it in this scenario is, and this is what we'll do in the demo. On the Prisma side, again, how it works is you need to define your data model. You then deploy that service, which migrates your database and gives you a GraphQL API endpoint that you can use directly. And in your GraphQL server, you just need to install the Prisma binding package. You put in the endpoint that you just got, and then you implement these resolvers in the way that we saw before. A typical, like if you're building a Node.js server, this is how a project could look like. On a high level here, you have your entire folder. If you're using Prisma, you typically have like a database folder which contains your Prisma YAML file and your data model. You can also split that up into multiple files, and you can also seed your services if you want. Then here we've put in all of our server files. Right now that's not really split up a lot, but you can handle this however you want. Your actual GraphQL server schema you typically express in our own GraphQL file. And here we have a couple of configuration files, package.json, and our GraphQL config, which we learned about before. So let's take a look at some of the files more in detail. So since one thing when getting started with this is like, whoa, there are a lot of these .graphql files. So what are they actually about? So what they have all in common is like uses GraphQL syntax, using also GraphQL STL. So here, data model, what we've seen before as a foundation for your service. Seed GraphQL. Here you can have GraphQL mutations, which are just initially executed. This Prisma GraphQL file is generated automatically, which represents the Prisma GraphQL schema that you have. So this is basically, this wouldn't need to be here, but this is needed for some of the tooling, such as GraphQL import, when we're using this, when we're importing some type definitions in our actual schema. And this is how the GraphQL config looks like. So here we have, in a GraphQL config, you have this concept of projects. So if you have, you can use this either in a front-end app where you have an iOS app, an Android app, and you have all of that in a big folder, or here where we have our database project and our actual server app project. In a GraphQL config, you typically have a schema path which links to this file over here, or the schema path for our database, and it has a bunch of extensions. So here an extension would be for the endpoints. So this is where we're hosting our node-based GraphQL server, and here we're using the Prisma extension, which is a shortcut that we don't need to write this out where our Prisma endpoint actually lives. Then let's take a quick look at how you would use the Prisma binding directly in your server. So you would install Prisma binding from npm, and what you then would do is you instantiate per request. You instantiate a Prisma object that you put on the GraphQL context. The context is like when you're familiar with Express middlewares, you always also have like this context object that's basically the same thing. So here we're just creating a new Prisma object, which just needs to know about the endpoint and the secret. And then you can just use it from within your resolvers, where on the context you then can access your database and you can delegate these queries. So that's essentially it, what you need to know about this. So let's use the last 5 to 10 minutes for demo. In this case, I'm using the GraphQL CLI and the create command, which uses, there's a project called GraphQL boilerplates, which is basically for Node.js or TypeScript or React. It has just like state-of-the-art boilerplate projects when you want to get started with a new GraphQL project. So this is what we can use directly with GraphQL create. Let's create a new project that's called London. I'm using the TypeScript advanced boilerplate. So what this is doing, it's like downloading it, already installs all of the dependencies, and in the boilerplate itself, there is all of the configuration already with GraphQL config, just that we have something to get started with. And this is also using Prisma under the hood. So, and to make this getting started easier, it already has like a default data model and wants to deploy it throughout the create command. So it prompts me here, hey, please select where you want to deploy this to. I just deploy this here to this cluster. Whoops, maybe the internet is not working. Let me just run it on Docker locally. 1 second. Have some patience with this little whale. Oops. One second. There we go. All right. So let me just deploy this one more time. And I just need to change the cluster where I want to deploy this to. So here I just change this to local. Say Prisma deploy. So this basically starts this from scratch, seeds a bit of data, generates my my GraphQL schema, and spits me out my GraphQL endpoints, which I could use here directly. I just need to now copy them in here. I'll walk you through the setup now. So this is fairly similar to what we've seen before. You have a database folder which contains the data model. Here we have a user and posts. In the Prisma YAML file, all of the meta information is configured. Here we're basing this on environment variables. So these environment variables coming from a .env file. And we have a bunch of seed data that we can get started more easily. Then in the source folder, we have the foundation for our GraphQL server. So here we're using Yoga to start a new GraphQL server, which uses this schema here. The schema is very simple. Here we have a feed query, we have drafts, we have a post, and we have me as an authenticated user. And the actual post, the actual post type we import from our generated Prisma GraphQL. Here, the GraphQL config, already as we looked at before, we just configured the GraphQL server app and the database. Here we configure the schema path. And what's important here is we configure how we want to generate a static GraphQL binding. So this basically just points to where the binding file should be saved at. And we are saying, OK, we want to use the TypeScript Prisma generator. So let's take a quick look. Again, this is the entry point for our server. Let's take a quick look at how some of these resolvers are implemented. So let's take a look at the query resolver. The query resolver looks something like this. We have, for a feed query, we just delegate to the posts, to the published posts. And we have also a drafts query, which delegates to also some posts, but the unpublished posts, which belong to me as an authenticated user. So I would suggest let's just take a look of how that works in action. So what I can just do is I can run yarn dev, which starts the web server, and it starts up my GraphQL playground. Let's make that a bit bigger. So can you all see it? Perfect. So let's explore the schema here. We can see, OK, we have feed. For a feed, we want to have a D, title, and the text. So let's just query that. And this is some data that has been seeded. Let's also try out the drafts. Let's try that. Whoops. We get not authorized, so which is sort of expected because this implementation looks like this, that it asks for the user ID, which checks, oh, do we have an authorization header set? If not, throw an error. So we just quickly need to sign us up. Email test.com. No time for good code style here. And name. Trump. And let's back get the token. Just get the token here. Let's set them as an HTTP header. If you want to try out Prisma, you can just install it like that from npm. Run Prisma init. And yeah, on prisma.graphql.com, you should also find some resources and tutorials to get started. Couple of notes still on Prisma. Right now, we're supporting MySQL, which you can also use with AWS Aurora. But over time, we're going to add more and more support for all sorts of databases. Postgres is one of the next ones, but also MongoDB, DynamoDB. So we really want to enable you to use GraphQL as a universal query language for all sorts of databases. And it will also be soon possible that you can use it with your existing database. Right. So as already Gerard and Søren said, it would be really awesome to see some of you at this year's GraphQL conference. We have pretty much everybody of the GraphQL core team from Facebook there. We have the guys from Apollo there. And we have some fantastic speakers that are flying over from Australia, Asia. And last year was already awesome. So I cannot wait for this year. Søren and I gonna be around for the rest of the evening. I think we're also gonna grab some beer with some of you if you're interested. And yeah, thanks.